This is Edexcel A-level Mathematics, Paper 2, Pure Mathematics 2 for the 2019 exams. Question 1 says, given that 2 to the power x multiplied by 4 to the power y equals 1 over 2 times root 2, express y as a function of x. To write this equation in terms of x and y, we can write all of these terms as powers of 2. So for example, 4 to the power of y can also be written as 2 to the power of 2y, because 2 squared is 4. So we could write this as 2 to the power x multiplied by 2 to the power of 2y. And this one here we can also write as a power of 2. So let's do a bit of work over here to prepare this one. This would be, well, we've got 1 over 2 root 2. 2 root 2 can be written as, well, we've got 2 to the power 1 times 2 to the power of a half. That's what root 2 is, 2 to the power of a half. If I combine these, 1 plus a half is 2 to the power of 3 on 2. So 1 over 2 root 2 is the negative of this, or the negative power of this. So this can be written as 2 to the negative 3 on 2. So all of that is to say, I can write this term here as 2 to the power of negative 3 on 2. And now I have it all as powers of 2. I can equate these powers. So I can say that x plus 2y equals negative 3 on 2. And then we need to rearrange this in terms of y. So then subtract the x from the right hand side. We'd have negative 3 on 2 take x on the right hand side, and then divide through by 2. So we'll have y equal to negative 3 on 4, subtract x on 2. And that is my final answer there for part 1, or question 1, for 3 marks. Question 2 says the speed of a small jet aircraft was measured every 5 seconds starting from the time it turned onto a runway until the time when it left the ground. The results are given in the table below with the time in seconds and the speed in meters per second. Using all of this information, part A says estimate the length of runway used by the jet to take off. Okay, so we have it turning onto the runway and its speed is 2 meters per second, and then taking off it's at 42 meters per second, and that total time is 25 seconds. Now to work out the total distance here, we can think of this as 5 separate distances. So the distance that's traveled from 0 to 5 seconds, the distance that's traveled from 5 to 10 seconds, and we can find all those distances and add them up. So to find each separate distance, I'm going to use s equals a half u plus v times t. So this is the initial speed plus the final speed times the time it's taken, and that's going to give you the distance traveled. So for this first part here, I would have a time of 5 seconds. Each section is going to have a 5-second time, and the initial speed is 2, the final speed is 7. So I'll have u plus v of 7, and all of that is multiplied by a half. Now, if I do that each time, I'm going to be multiplying each thing by 5 seconds. So you could do this for each one and add them up, or we could factorize the 5 out, factorize the half out, and in the brackets then, all we need to do is add up the speeds. So 2 plus 5 is 7, plus 5 plus 10 is 15, plus 10 plus 18 is 28, plus 18 plus 28, that's 46, and 28 plus 42, that's 70. Okay, now there are different ways to do this, but this is the approach I took. So basically adding these up, I might just get a calculator just to make sure I don't make any mistakes. And so I'm doing 7 plus 15 plus 28 plus 46 plus 70, and then multiplying that by 5 on 2, and I get 415 for my total distance traveled. Okay, on to part B. Part B says, given that the jet accelerated smoothly in these 25 seconds, explain whether your answer to part A is an underestimate or an overestimate of the length of the runway used by the jet to take off. So what I was doing here is essentially saying each distance is kind of like a trapezium. That's what that is, right? That's the trapezium. That's the area of a trapezium. So we're saying that this graph would look like this, right? Each section a straight bit, okay? And we were finding these areas. Okay, so we're finding those areas and adding them up. What's actually happening is the jet is accelerating smoothly. So to find the actual area, we would want to integrate that to find the actual distance. So, well, what's happened then? Well, if we were finding the area of the trapezia there, well, those lines actually will be just slightly an overestimate. Okay, so because they are, because the graph is convex, the curve is convex, that is one way to explain it. So basically the curve is going this way, so the straight lines are going to be above it. So that's going to be an overestimate for part B. So my answer, an overestimate as the graph is convex or the curve is convex. So final answer, an overestimate as the curve is convex and the top of the trapezia lie above the curve. Okay, that was question 2 for 4 marks. Question 3 gives us a diagram and it says figure 1 shows a sector AOB of a circle with center O, radius 5 centimeters and angle AOB equals 40 centimeters. The attempt of a student to find the area of the sector is shown below. Okay, we have area of the sector equals half radius squared times theta. That seems okay with me. Then they've plugged in those numbers, except this formula is for radians and they've plugged in degrees. So part A says explain the error made by this student. That would be my error. They need to use radians and not degrees. So for part A, explain the error made. They used, or they did not use, theta should be in radians. Okay, so that was part A. Part B, write out a correct solution. Well, for this, we can convert 40 degrees to radians and then plug it into the formula. To convert degrees to radians, you multiply by pi on 180. So 40 times, or 40 on 180 times pi, either way. This is equal to, if we cancel this, we could divide by 10 and then 2. So this would be 2 over 9, or 2 pi over 9. Radians. Okay, and then plugging that in, we would have the area equal to a half times the radius squared times 25 and multiplied by the angle, 2 pi on 9. And then, well, I guess put that straight into a calculator. We have 0.5 times 25 times 2 pi on 9, and that gives me 8.72 or 732, 3 significant figures. So 8.73, and I should use an approximation symbol there to show that I've rounded off to 3 significant figures. And what was the units? We were talking about centimeters. So the area of the sector will be 8.73 centimeters squared for a final answer there. And that was question 2 for 3 marks. Question 4 gives us a diagram and it says the curve C1 with parametric equations x equals 10 cosine t and y equals 4 root 2 sine t, where t is between 0 and 2 pi, meets the circle C2 with equation x squared plus y squared equals 66 at 4 distinct points as shown in figure 2. Given that one of these points S lies in the 4th quadrant, find the Cartesian coordinates of S. Okay, so we have an ellipse and a circle, and they're meeting at S, and we want to find the coordinates of S. Before we start, I want to say there are at least 5 ways of solving this question. I'm only going to go through one method, but if you have a different method to this, there are at least 5, and there are 5 in the mark scheme, so check that out if I do not cover the method that you used, or the method that you would like to use. So my method is going to involve finding the Cartesian equation of this ellipse and then essentially equating the coordinates to find S. So let's start off by saying that the curves meet when their coordinates are the same, right? Curves meet when the x and y coordinates of C1, curve 1, equal the x and y coordinates of C2. Now, we should get 4 answers to that, but we will know the answer we get is correct when we have a positive x value and a negative y value, because they've given us the diagram and they've told us where what coordinates to look for. So that's really helpful here. Otherwise, we would have 4 solutions. So to start off with, we know the equation for the circle. They've told us that it is x squared plus y squared equals 66. And then what I want to do is essentially rearrange this in terms of x, plug that into the equation for the ellipse, and then solve for y. And then I should be able to find my coordinates here. So rearranging this in terms of x, we would have x squared equal to 66 take y squared, and then x equal to the square root of 66 take y squared. And we do not have to include the positive or negative, or I'm not going to, because I'm going to say as we know that at s, x is greater than 0. So we know that x is positive, so we don't, or I'm not going to include the negative solution there. Okay, then for an ellipse, we know that the general form of the Cartesian equation is x squared over a squared plus y squared over b squared equal to 1. In this case, or I should say those a and b values, they come from the coefficients of the cosine and the sine functions here. So a, we call the coefficient of cosine t. A is equal to 10 and b is equal to 4 root 2. So I might write those down below as well. So a equals 10, b equals 4 root 2. Plugging those in, we would have x squared over 100 plus y squared over 4 root 2 all squared. That would be 16 times 2. That would be 32 equal to 1. And then simplifying this, I would have 32x squared multiplying by 32, and then multiplying everything by 100. 100 y squared equals 32 times 100, 3,200. Okay, so now I have an equation for the ellipse, and what I want to do is to plug in this value of x into this equation, and then hopefully be able to solve for y. Okay, so I might go on to the next page for that. Plugging that in then, I had x from the circle equal to 66 take y squared, x squared, actually using this equation, this one here, plugging that in for x squared here, just to be really clear, I get 66 take y squared plus 100 y squared equals 3,200. And then expanding these out, 32 times 66, might go to the calculator for that one. 32 times 66, 2,112. Take 32 y squared plus 100 y squared equals 3,200. And then simplifying further, negative 32 plus 100, that's 68 y squared equals 3,200 take 2,112. Again, going to go to the calculator for that one. Take the answer and I get 1,088. And then divide that by 68 to get y squared. Divided by 68, 16. And so we get a rather nice, neat answer for y of plus or minus 4. Now, okay, let's just write plus or minus 4 down, but let's recognize that s was in that fourth quadrant and we're looking for a negative value for y. So therefore, we get a value for y of negative 4 as at s, y is less than 0. Now we have a value for y. Let's plug that in either to, this equation or wherever. So if we plugged it in here, we would have 4 squared is 16. 66 take 16 is 50. So we get x equal to root 50. So therefore, x is equal to square root 50. And that's a positive. So also we could simplify this. And I'll just check the question again. It says, well, it doesn't say to simplify, but I think it's good practice to simplify your surds. So 50 can be written as 25 times 2. The root of 25 is 5, so this can be written as 5 root 2. So then that point S, my final answer, is the x coordinate is 5 root 2, the y coordinate is -4. Okay, so that was my working and my answer to question 4 for 6 marks. Again, there are different methods to do that, so check the mark scheme out for those other ways of doing it. Question 5 gives us a diagram and it says, figure 3 shows a sketch of the curve with equation y equals root x. The point P, xy lies on the curve. The rectangle shown shaded in figure 3 has height y and width delta x. Calculate the limit of delta x approaching 0 from 4 to 9 of root x delta x, or dx. So this is a fancy way of saying that you need to find the integral from 4 to 9. So try not to get bamboozled by this notation here, or you might have seen this before and you know exactly what it's talking about. Anyways, we're looking for this integral from 4 to 9, and let's go ahead and write that down. So for the integral from 4 to 9 of y with respect to x, this is going to be the integral from 4 to 9 of root x dx, and then we need to integrate root x. Well, think of it as x to the power of a half, or that makes it easier for me to think about anyways, because then I use the power rule for integration. So add 1 to the power, divide by that power. Dividing by 3 on 2 gives us a coefficient of 2 on 3, and then it's x to the power of 3 on 2 from 4 to 9. So plugging 9 in, we would have 2 on 3, 9 to the power of 3 on 2. That's like the square root of 9 to the power of 3. Actually, I'll just make a note to the side where I'm doing a 9 to the power of 3 on 2. This is like 3, the square root of 3 cubed. Sorry, the square root of 9 cubed, not the square root of 3. Square root of 9 cubed, which is 3 cubed, which is 27. Okay, so plugging that in then, 27, and then I want to subtract plugging 4 in. So again, we would do, or I would do the square root of 4, which is 2 cubed, would be 8. So 2 on 3 times 8. And then, well, evaluating this, 27 divided by 3 is 9, times 2 is 18. Subtract 8 times 2 would be 16 on 3. So I guess that's the easiest way to write that. And then 18 take 16 on 3. That would be the same as saying like 5 and a third. So 18 take 5 is 13. So we'd end up with 12 and 2/3. Okay, so that would be my final answer there for question 5 for 3 marks. Question 6 starts off with the diagram and it says figure 4 shows a sketch of the graph of y equals g of x, where g of x is equal to x take 2 all squared plus 1 when x is less than or equal to 2, and g of x is equal to 4x take 7 when x is greater than 2. Part A says find the value of g of 0. So well, we need to find g of 0 first and then plug that into g. So g of 0 is going to belong to this expression, or this domain, when x is less than 2. So plugging 0 in here, that will give us g of 0. So let's start off with that for part A. Didn't mean to do that. Okay, there we go. So for part A, we're doing g of 0. Again, plugging that into the first expression would have 0 take 2, negative 2, all squared is 4, plus 1 is 5. So g of 0 is 5, and then g of 0 is g of 5. That fits into the second domain here, x greater than 2. So plugging x equal to 5 into this one, 4 times 5 is 20, take 7 is 13. So g of 5 will be 13 for a final answer there for part A. Part B says find all values for x which g of x is greater than 28. So I'm going to do this algebraically, but I'm going to also check the graph first to get a rough idea of where my answers will be. So we're looking for y values greater than 28. Let's say 28 was here. I have no idea if it would be, but let's say it was. We are looking for the y values when the graph is above this. So actually, we're going to get some x values that relate to these values, and we're going to get the x values less than this one over here and greater than this one. So we want less than some negative number, greater than some positive number, and well, let's see what we get algebraically. So that's just a rough check to get a good idea of what I want to do. So using the first expression, I had x take 2 all squared plus 1. That needs to be greater than 28. And I had 4x take 7. That needs to be greater than 28. Okay, solving these algebraically. Also, I need to keep the domains in mind. So this domain here was when x was less than or equal to 2. And this one was when x was greater than 2. That's going to influence my final answers. Okay, solving this one algebraically, we have x take 2 all squared greater than 27. And then taking the square root of both sides, I'll actually have two possibilities here. I'll have x take 2 greater than the square root of positive 27, or x take 2 less than negative square root 27. So when you're taking the square root and you've got a negative, it's the same effect as multiplying or dividing by a negative number. You need to flip those inequalities because you're essentially taking that negative from the left to the right hand side. I'm not going to go into that any deeper. Apologies if you're not clear on that, but I could spend 5 minutes talking about it, but I'm going to move on. So check that out with inequalities and square roots if you're not sure about that. Anyways, moving on. We would have, for this one, we would have x greater than the square root of 27 plus 2. And for this one, we'd have x less than the negative square root of 27 plus 2. Now, this is where we need to consider the domain. This expression was for x less than or equal to 2. This value here, well, the square root of 25 is 5. This would be over 7. So this is not fitting in with this domain. So we can ignore this one. So we can say, therefore, x is less than the negative square root of 27 plus 2, as x is less than or equal to 2. For this particular expression, that is, I guess, my first boundary for x. And then this one should be a little bit easier. We've got 4x greater than 28 plus 7. That's 35. And then x greater than 35 on 4. So to finish this off, I would say, therefore, g of x is greater than 28 when we have x less than negative 27 plus 2 and x greater than 35 on 4. Okay, that was part B. Part C says the function h is defined by h of x equal to x take 2 all squared plus 1, where x is less than or equal to 2. Explain why h has an inverse but g does not. This is essentially a quadratic, but it's only half of a quadratic. So let's look at the graph again. We're looking at this part here. Let me rub all of this out first. So we're looking at this section of the graph, just less than 2. So, well, this is basically one-to-one graph. For every input, for every x value, we get one y values. But for g of x, we're also considering this part of the graph. And for that one, we have, for every output, we have two inputs. So there's two x values, two possible x values for each y value. And when we have that many-to-one relationship in a function, then we don't have an inverse. So we can say then that h of x is 1-to-1. For part C, h of x is 1-to-1, but g of x is many-to-1. So final answer, h of x is 1-to-1, but g of x is many-to-1, so does not have an inverse. For part C, and then part D says solve the equation the inverse of h of x equal to -half. Now, there is a long way of doing this, which is what I initially started to do. So you can find the inverse of h of x and set that equal to -1/2. But there is a little trick here, and we can say that, well, what does this mean if the inverse function is equal to -1/2? This is saying if the input is equal to -1/2, what's the output? Remember, that's what the inverse function is. That's what it's asking. It's giving you the input for every output. So what this is saying is x is equal to -1/2 in this expression. So all we have to do is plug in negative a half for x here, and we will get the answer to this equation. So h of negative a half is what I'm looking for part D. So h of negative a half, and we had negative a half take 2 all squared plus 1. This is negative 3 on 2 squared would be 9 on 4 plus 1. This is like 2 1/4 plus 1, so 3 1/4. Okay, now it does work if you do it the other way around, like I was saying. If you find the inverse function, set that equal to negative a half, it still works out, but that is maybe a little trick or a shortcut to that question for part D. And that was question 6 for a total of 10 marks. Question 7 says a small factory makes bars of soap. On any day, the total cost of the factory, Y pounds, of making X bars of soap is modeled to be the sum of two separate elements. A fixed cost, a cost that is proportional to the number of bars of soap that are made that day. Part A says write down a general equation linking Y with X for this model. This question will be slightly easier if you study economics, because you'll know straight away this should be a linear function, right? We have a fixed cost, that's just one cost per day, and then we have the cost proportional to the number of soaps. That's a linear relationship, so we're going to have a linear graph, and you can write that however you like. You could write y equals mx plus c, or I will just use ax plus b, however you like, but you have a linear graph with ax being the proportional amount and b being the fixed cost. And we could say y equals the cost, the total cost, and x equals the bars of soap. Okay, so that was part A. Part B says the bars of soap are sold for £2 each. On a day when 800 bars of soap are made and sold, the factory makes a profit of £500. On a day when 300 bars of soap are made and sold, the factory makes a loss of £80. Using the above information, part B says show that y equals 0.84x plus 428. So this is essentially a simultaneous equations question, right? They give you two bits of information. We can come up with two separate equations and solve for, or come up with this equation y equals 0.84x plus 428. So solving for A and B in this case. Okay, so let's go ahead and create these equations. We've got the first piece of information they say is the price of the soap is £2. And then they say when the number of bars of soap, which I've called x, so when x equals 800, the profit equals £500. Also, if we make and sell 800 bars of soap and we know the price is £2, well, we've made £1,600, right? So we call that number revenue. Total sales is 800 times 2, £1,600. Then we also know when x equals 300, so 300 bars of soap are made and sold, the profit was a negative. Well, they called it a loss in the question. They said the factory makes a loss of £80. So I could also say profit equals negative 80, same thing. And well, we also made a revenue, the total money made, bars sold times the price, £600. Okay, the next part of this is to say that the profit equals the revenue, total money made from sales, take the cost of producing those bars of soap. Okay, now my first equation here, using that first bit of information, this will be my second equation. I'm going to say that the profit, which was £500, equals the revenue, which was £1,600, take the cost. Now remember I said y was the cost, so I'm going to use this expression here for cost. This will be A multiplied by the number of bars of soap, which was 800, plus B. Okay, so I've got those two unknowns, A and B, and now I want to simplify this a little bit. I could swap it around. subtract that 1600 from the left hand side. So I'm going to write this as negative 800A take B equals negative 1100. Oops, let me just rewrite that. Negative 1100, and then dividing through by negative 1 and adding that 800A to the other side, I have B equal to 1100 take 800A. Okay, hopefully you can follow the algebra there. And moving on to the second equation, hopefully then this starts to make more sense if it is not already. Using the second piece of information, we are saying again the profit in this case was negative 80 on this day is equal to the revenue 600 take the cost, which is this expression. So subtract A times 300 with the X value plugged into this expression. Oops. 300 plus B. Okay. And then simplifying this similarly to how I did over here, making B the subject, I would have negative 300A take B equals negative 680. Negative 80 take 600. And then B is equal to 680 take 300A. Okay, now I have both expressions in terms of B. I can set those equal to each other, solve for A, and then solve for B. So therefore I have 1100 take 800A equal to 680 take 300A. And then 1100 take 680, that's 420. And actually I might write the A on the left hand side. So negative 300 plus 800 is 500. A equal to 420. And then A is equal to 420 divided by 500. Sorry, 420 divided by 500. I get 0.84. That's really good news because that is what I was looking for. And then plugging that into either of these two equations, we could say that B is equal to 1100 take 800 times 0.84. Plugging that in, I get 1100 take 800 times 0.84. I get 428. Again, really good news. And again, taking this expression, y equals ax plus b. So y equals ax plus b. It follows that y equals 0.84. Plugging that in for a. X plus 428. Plugging that in for b. Okay, so that was part B there. Show that y equals 0.84x plus 428. Part C says, with reference to the model, interpret the significance of the value of 0.84 in the equation. Well, they kind of told us that in the initial part of this question. They said there's a fixed cost. That's going to be this 428. The cost that is proportional to the number of bars of soap. That's this 0.84x. Well, for every bar of soap, the cost is going up by 84 cents. So I guess to answer that question, the significance of 0.84, it's the cost per bar of soap. So for part C, I would write something like the cost of making each extra bar of soap. Okay. Part D. Part D says, assuming that each bar of soap is sold on the day it is made, find the least number of bars of soap that must be made on any given day for the factory to make a profit that day. Okay, let's start on part D. So we're looking to make a profit. Well, firstly, let's state what the revenue is, the total made from sales. Well, each bar of soap is sold for £2, so the revenue is 2 times the number of bars of soap sold. And remember, we're assuming each bar of soap made is sold that day. So each bar of soap is sold on the day it is made. So the number of bars of soap made is the same as the number of bars of soap sold. So revenue is 2x, and also I know the cost, or the expression for cost, is 0.84x plus 428. So we make a profit when the revenue, the total made from sales, is greater than the cost. So I could write this as 2x, the revenue, greater than the cost, 0.84x plus 428, and then solve this for x. So doing this over here, I'd have 2x take 0.84, that is 1.16x, greater than 428, and then divide through by 1.16, 428 divided by 1.16, and I get 368.96. So I might just write that number down, 368.96. And then think about what that means in terms of bars of soap. If x is greater than 368.96, well, we can't have 0.96 of a bar of soap, so we would want x to be greater than 369 to make a profit. So to answer the question, the least number of bars of soap to make a profit, that would be 369. So I would write that in a sentence to finish this off. So the least number of bars of soap to make a profit is 369. And that was question part D for question 7, and that was a total of 7 marks. Question 8 says find the value of the sum of 20 times half to the power of r from 4 to infinity. And part 2 says show that the sum of log base 5 of n plus 2 over n plus 1 equals 2 for 1 to 48, n equals 1 to 48. Can I just say I love these shorter questions, the less wordy ones. But anyways, for the first one, we're going to want to use the infinite sum formula for a geometric series. And we also need to find the first term. So actually, let's go ahead and firstly write down that formula for part A. So we're looking for the the infinite sum of a geometric series. And that formula is A over 1 take R. And this really only works when r, or the absolute value of r, is less than 1. And I should use a different variable there. That's generally the variable used in this formula, but it's not this r. So it's different to this r here. The r in this one is the ratio between the terms. So in this case, we are multiplying by a half each time. So the r in this formula will be a half, the number in these brackets, not the power here. Sorry if that's confusing. Now, to use this formula, I want to find a, which is the first term. So I'll just write that down. A is the first term in the sequence. Now, with this sum, we're starting at r equal to 4. So 20 times a half is not going to be my first term. So firstly, I need to do a little bit of work to find a. So a is going to equal 20 times a half to the power of 4, right? We're starting at r equal to 4. So that power there is equal to 4. So let's go ahead and, well, we don't even really need to evaluate that. We could just plug it straight in and then put all of that straight into a calculator. So then my sum of this infinite series is the first term, 20 times a half to the power of 4, all over 1 take r, r being a half, as I've already explained. So then let's go ahead and evaluate this. We would have 20 multiplied by 0.5 to the power of 4 divided by 1 take a half is just a half, and that should give us our final answer. So the infinite sum here is 2.5. Okay, so essentially converging on 2.5. So final answer there for part A, 2.5. Then part 2, we want to evaluate this sum. And for this one, I'm not really exactly sure how to evaluate it, but I know it's not a geometric series, or I'm pretty sure it's not a geometric series. It's not an arithmetic sequence. So when it's a sum that I'm not sure about, I would generally just write the terms out, or start by writing the terms out and see what I get. So for the first term here, n equal to 1, I'd have log base 5 of 1 plus 2 over 1 plus 1. So 3 on 2, plus the second term, log base 5 of n equal to 2. This would be 4 on 3, plus log base 5 of 5 on 4. And hopefully you're seeing a pattern now. If we went all the way up to n equal to 48, we'd have log base 5 of 48 plus 2 is 50 on 49. Okay, so that would be if I expanded that sum out, and I'm trying to show this equals 2. So how could I simplify this now? Looking at this expression here, well, if we've got log of 3 on 2 plus the log of 4 on 3, another way of writing that is log of 3 on 2 multiplied by 4 on 3. So here I'm going to be using this law, the log of A plus the log of B equals the log of A times B. Okay, so then I could write all of this because they're the same bases, the log of the same base. This works out. So I've got 3 on 2 times 4 on 3 times 5 on 4 times 6 on 5, and we go all the way up to 50 on 49. And now, hopefully you notice something, right? If we're multiplying all of these fractions together, we could do cancelling. So what could we cancel? Well, there's a 3 in the numerator and a 3 in the denominator, a 4 and a 4, a 5 and a 5. So actually, everything would cancel here. We'd have a 49 over 48, and the 48s would cancel. Everything would cancel except what? What would we be left with? Well, there's no 2 in the numerator, and there's no 50 in the denominator. So we'd be left with log base 5 of 50 on 2, because everything cancels. Everything cancels out. And how can we write this? 50 on 2, that's 25. So log base 5 of 25. Hopefully you know how to evaluate logs. This is saying what is the power of 5 when I have the input of 25. Well, you know 5 squared is 25. So the power of 5 when I have the answer of 25 is 2. Okay, so there we go. We have shown that that sum is equal to 2. And that was question 8 for 6 marks. Question 9, back to the worded questions. Question 9 says, a research engineer is testing the effectiveness of the braking system of a car when it is driven in wet conditions. The engineer measures and records the braking distance d meters when the brakes are applied from a speed of v kilometers per hour. Graphs of d against v and log d against log v were plotted. The results are shown below together with a data point from each graph. Okay, there we have the graphs. Part A says, explain how figure 6 would lead the engineer to believe that the braking system should be modeled by the formula d equals k v to the power n, where k and n are constants, with k approximately equal to 0.017. For part A, we're using the second graph, or figure 6, and well, the first thing you'll notice is this is a straight line. So we're modeling log v against log d, so we could write this in terms of a straight line equation for part A. So log d, which was the y in, if we're writing y equals mx plus c, this equates to the y. This is equal to the gradient multiplied by x. And in this case, because they're using n here, I'm going to use n in this equation. N times x, in this case, my x-axis is log v. So n times log v plus the y-intercept. And they've given us the y-intercept here as well. It's negative 1.77. Okay, so that's actually a negative there. And now I have my equation, and I want to go ahead and simplify this as best I can. So log of d, well, firstly, I'll take that coefficient, raise it to the power of v. So this will be log 10 v to the power n using my log laws. And also, I want to write this as a log base 10. And basically, if you want to do that, you just say this is equal to 10 to the power 177, whatever that number is. The reason I've done that is because now I have both numbers as log base 10. I can write this as log base 10 of v to the power n over 10 to the power 177. because when we subtract logs with the same base, we can divide the terms inside those logs. Then, taking raising everything to the power of 10 to cancel out those logs, I would have d equal to v to the power of n over 10 to the power 1.77, or 1 over 10.177 multiplied by v to the power n, the same thing. And then going back to the question, I wanted k approximately equal to 0.017. If I evaluate this term here, hopefully I get what they're looking for. So 1 over 10 to the power of 1.77, I get approximately 0.17, rounding that off. Okay, so therefore d is approximately 0.017 v to the power n, and that is what they wanted. Okay, so that was part A. Part B says, using the information given in figure 5 with k equal to 0.017, find a complete equation for the model giving the value of n to 3 significant figures. Okay, so we're using figure 5 now, and we've got that point 30, 20. And you'll notice the axes now are d and v. So essentially what I'm going to do is take that point, plug it into this formula I've found, and hopefully find a value for n. Okay, for part B, I'll say using 30, 20, plugging that in, I'll have 20 equal to 0.017, 30 for v to the power n, and now I have 30 to the power n equal to 20 divided by 0.017. 20 divided by 0.017, I get 1,176 approximately, 0.47. And then to find n, I could take log base 30. On my calculator, I do not have a change of base, so I'm going to have to use the change of base formula. So this is going to be log base 10 divided by log base 10 of 30. And this should give me log base 30 of 1,176. So I get 2.078 approximately. So therefore n is approximately 2.08. And then I have my complete equation. D is equal to 0.017 multiplied by v to the power of 2.08. And that was n to 3 significant figures. Okay. Part C says, Sean is driving his car at 60 kilometers per hour in wet conditions when he notices a large puddle in the road 100 meters ahead. It takes him 0.8 seconds to react before applying the brakes. Use your formula to find out if Sean will be able to stop before reaching the puddle. For this, we're going to have a distance before he hits the brakes and then the stopping distance after he hits the brakes. So we need to actually work out both of those distances, add them together, and hopefully that is less than 100 meters. So to firstly work out the distance before he brakes, 0.8 seconds, we're going to multiply that by his speed, 60 kilometers per hour. So for part C, we are going to firstly do, let's just write down his speed. It's 60 kilometers per hour. And we want this actually in meters because we're talking about 100 meters. So we want the distance before he brakes in meters. So distance before reaction. This is going to be the speed he's going multiplied by the time he's traveled. Now, to get the kilometers, we could say it's 0.8 divided by 3,600. That's the time in hours, 0.8 seconds in hours. And then we could multiply that by 1,000 to change the distance to meters. So, however you want to think about that, but that's the calculation you want to do. Divide by 3,600 multiplied by 1,000. And if we put that into a calculator, let's do 0.8 divided by 3,600 multiplied by 60 and then multiplied by 1,000. And we get 13.3, 13 and a third meters. So that's the distance he traveled before braking, and then we need to use our model for the braking distance. So remember, this is the model used to determine braking distance. So our model, now let's just interpret what our model actually means. D was the distance, the braking distance. V was the initial speed that the car was traveling. So going back to this equation, the distance is all we need to really do here is to plug in, this one here, all we need to do is plug in V of 60 and we should get our braking distance. So we can say D is equal to 0.017 multiplied by 60 to the power of 2.08. Putting that in now, we can say this will be 0.017 multiplied by 60 to the power of 2.08. And I get 84.91 or 84.9 approximately. 84.9 meters. So total distance that he's traveled after seeing the puddle initially would be 84.9 plus 13 1/3. And well, it's going to be less than 100, but let's just get a number. We get 98.25. Let's write that down, 98.25 meters, and that's approximately. So to answer the question was saying determine or to find out if Sean will be able to stop before reaching the puddle. Yes, he will. Okay, so yes, Sean will stop before reaching the puddle. And I think that was everything for this question. So that was part C for 3 marks and total of 9 marks for question 9. Question 10 gives us a triangle and it says figure 7 shows a sketch of triangle OAB. The point C is such that OC equals 2OA. The point M is the midpoint of AB. The straight line through C and M cuts OB at the point N. Given OA equals A and OB equals B, find CM in terms of A and B. Okay, so let's go ahead and draw these points in. We have a point C such that it is double or the same length as OA. So then OC would be 2OA. So C would be out here somewhere. Actually, let's just draw that line in first. So C would be about out here. So then OC is 2OA. And we have M, which is the midpoint of AB, about here. And then we have the straight line CM, which cuts the line OB at the point N. So we have this straight line that goes down to OB, and this point would be N. Okay, and we also are told that OA is the vector A and OB is the vector B. Alright, so now we want to find CM, this one here, in terms of A and B. Well, the first thing we could do is find AB, this line here, or this vector here, and then find AM, which is going to be half of that, and then we can go from C to A and then A to M, and we'll have that vector in terms of A and B. Okay, so firstly, AB, the vector AB is going to be negative A plus B, or B take A. So starting A down here, we've got the vector AB is equal to B take A, and then AM, because M is the midpoint, AM is going to be half of that. And then again, looking at the diagram, CA, well, we know that OC is twice OA, so that means this part in here must be A as well. So CA is going to be negative A, and then therefore CM is going to be negative A plus AM, which we just found. So CM is going to equal negative A plus a half B take A, and this evaluates to a half B, negative A take a half A, that would be negative 1.5a or negative 3 on 2a. So that is the vector Cm. Next, part B says show that On equals 2 take 3 on 2 lambda a plus a half lambda b, where lambda is a scalar constant. And part C says hence prove that On to NB equals 2 to 1. Okay, so where is the vector On? That is here. So how would we get from O to N? We could go from O to C and then C to N, or we could go from O to A to M, M to N. Either one will be fine. I'm going to do OC plus CN. So ON for B, ON is equal to OC plus CN. And we know OC, that's 2A. And we can say that Cn, because CMN is a straight line, they tell us that in the question, we know that Cn must be a multiple of Cm. So we would have some scalar multiple of Cm. And for this, I'm going to use lambda like they've done in the question. So we've got lambda Cm, some scalar multiple of Cm, and expanding that out, we'll have lambda multiplied by a half b take 3 on 2a from part A, and then we'll have 2a plus a half lambda b take 3 on 2 lambda a, and then combining the like terms, we would have this equal to 2a take 3 on 2 lambda a, or we could write that as 2 take 3 on 2 lambda, and then factorize the a out, write that out the front, plus a half lambda b. And that is in the form that they want us to write it in, I believe. Yes. Okay, so then C says hence prove that On to NB equals 2 to 1. For C, well, let's go to the diagram. We're looking at the vector On, and we know OB is vector B, so On is going to be some multiple of B. There is no A component of this On vector, right? It's all going to be the B vector. So for this expression, On, this vector On, this would be equal to 0. This coefficient of the A vector, that would be 0 because this needs to cancel out. So setting that equal to 0 then, we'll be able to solve for lambda. So 2 take 3 on 2 lambda equals 0. And then negative 3 on 2 lambda equals negative 2. And then we would have lambda equal to 4 on 3. So then plugging that back in here, we would have On equal to half times 4 on 3 b. So just taking that term there, plugging it in, and then this would cancel to 2 on 3 b. So On is 2/3 of b. B was NB, the vector NB. Sorry, B was the vector OB. So if this length here is 2/3 b, then that means that the ratio of On to NB must be 2 to 1. Okay, so the ratio then of On to NB we can say equals 2 to 1. All right, so that was part C. Now there is a slightly different way to do that question. I'm going to just show that quickly, just in case anyone was curious. So we had an expression for Cm. This was equal to a half b take 3 on 2a, and then we said Cn, or we looked for an expression for Cn. Now we know that Cn would be negative 2a plus some fraction b, so we could say Cn would be negative 2a plus kb, and then we can look at the coefficients of a and say that negative 3 on 2 times something needs to equal negative 2, because this is a straight line. Again, we're using that idea that Cmn is a straight line, just doing it slightly differently. So then we are multiplying this vector Cm by 4 on 3 if you solve for k there. So then we could say that in here, we've got b multiplied by 4 and 3, so Cn is equal to negative 2a half b multiplied by 4 and 3, which is 2/3 b. Okay, so then you get the idea that ON would be 2/3 b as well. So a slightly different method there in case anyone was curious, but given that they ask you to show that ON equals this, I wouldn't suggest you use that method, but in my opinion that's actually a more efficient way of solving it. But anyways, just in case anyone was wondering. Okay, that was question 10 for 6 marks. Question 11 gives us a graph and it says figure 8 shows a sketch of the curve C with equation y equals x to the power x, where x is greater than 0. Part A says find by firstly taking logarithms the x coordinate of the turning point of C, and solutions based entirely on graphical or numerical methods are not acceptable. Basically saying you need to use calculus for this. So well, let's firstly take this equation, and well, what does this mean? If we're looking for the x coordinate of a turning point, that means we want the derivative. So the derivative is going to lead us to the turning point of the graph. So for part A, that will be where I want to start. So firstly, I've got y equals x to the power x. And the question tells us to use logarithms. So let's go ahead and do that. Let's take the natural log of each side. And then using our log laws, we know that log of x to the power x, that's going to equal x times log x. And we want the derivative out of this, we want dy and dx, so we're going to have to use implicit differentiation here. So taking the derivative of either side, you could either do it with respect to y or x, either way it's still going to work out. So doing this with respect to y, we could say this is the derivative of log y with respect to y, and then the derivative of x log x with respect to y, that's not going to work, so we're going to have to introduce sorry, that's not meant to be dx. We're going to have to introduce a dx on dx, so that gives us the derivative of x log x with respect to x, and then we need to multiply that by dx on dy. So introducing a dx on dx, effectively we still have d on dy there. So taking the derivative with respect to y gives us this, and then if we continue with this derivative, the derivative of log y is 1 on y, and the derivative of x log x with respect to x, you can either use the product rule on that, or you may know that this is log of x plus 1, and this is multiplied by dx, not dy, dx on dy. And then rearranging this in terms of dy and dx, we would have dy on dx equal to y multiplied by log of x plus 1. Okay, so we have the derivative of that curve equal to y log x plus 1, and we want to let this equal to 0. So I might do this on the next page. So when dy and dx equals 0, we will have y log x plus 1 equal to 0, and there are two solutions here, right? We have y equal to 0 or log of x plus 1 equal to 0. From here, there are a couple of approaches you could take. So you could just look at the graph and you can say there's clearly no solutions there where y equals 0, because this graph is not cutting the x-axis. So there's no y equals 0, there's no coordinates at y equals 0. Or you could also just prove this algebraically by plugging in x to the power x for y, because we know y equals x to the power x. So this could also be written as x to the power x times log x plus 1 equals 0. And for this graph, they tell us the domain, x is greater than 0. So the only solutions here then are if log of x plus 1 is equal to 0. Also, x log x cannot equal 0. So in this case, we've got log x plus 1 equal to 0, therefore log of x is equal to negative 1. And raising both sides to the power of e to get rid of that natural log, we would have x equal to e to the negative 1. Okay, so that is my final answer for part A. The x coordinate of the turning point is e to the power of negative 1. Part B says the point P alpha 2 lies on C. Show that alpha is between 1.5 and 1.6. So for this, we can essentially plug those in to this equation for x. alpha for x, and then hopefully we get numbers either side of 2 to show that when alpha is between these numbers, then we would have the coordinate of 2, the y coordinate of 2. Okay, so for part B, we are given the point P alpha 2, and so then we can plug in 1.5 for x. So we know y equals x to the power x, so this would be 1.5 to the power of 1.5. Let's put that into a calculator. So 1.5 to the power of 1.5, I get 1.837 approximately, 1.837, and then the other bound was 1.6, so 1.6 to the power of 1.6, 1.6 to the power of 1.6, I get 2.121. That's exactly what we wanted because they are either side of 2. So we can say then alpha must be between these numbers somewhere to get a y coordinate of 2 or a solution of 2. So just to finish this off, let's add some details. Well, let's show that we clearly notice 1.837 is less than 2, and we clearly know that 2.12 is greater than 2, and we also know that C is continuous about that point or through that point because we're given the diagram. Okay, so this is showing a continuous curve, so we can assume that it's continuous, therefore we know that alpha is between 1.5 and 1.6. Okay, on to the next one. Part C says a possible iteration formula that could be used in an attempt to find alpha is x sub n plus 1 equals 2x sub n to the power of 1 take x sub n. Using this formula with x sub 1 equal to 1.5, find x sub 4 to 3 decimal places. Okay, so this is going to involve plugging this into a calculator and iterating it a number of times. Let's firstly write down that formula. It was x sub n plus 1 equal to 2 times x sub n to the power of 1 take x sub n. And we were assuming that x sub 1 is equal to 1.5. Alright, so let's plug this into a calculator and see what we get. So we've got 2 multiplied by x, well, 1.5, which is our first term. And this is to the power of 1 take 1.5. And let's see what we get. Oops, I needed brackets there, hang on. Okay, if you have a newer calculator, hopefully you don't have to do that. Okay, let's see what we get. 1.632 and so on. Let's do that again. So go to your entry and then do the answer inside those brackets. And that's going to make it a bit quicker. There are some systems on calculators where this does it actually automatically. It has an iteration function, but I'm just going to do it this way. So the next one, this would be x sub 3, 1.466. And then if I go entry again, this will be x sub 4. So x sub 4, I can write that one out. And what was it? 3 significant figures? Sorry, let me just double check. 3 decimal places. 3 decimal places. So this will be 1.673 approximately. Okay, and let me change that to approximation, and that's 3 decimal places for x sub 4. And actually, I believe that they usually want you to show that you understand where to input the values. So you may have to write this out with the values plugged in. I'm not 100% sure about that. The mark schemes are not always clear, but you may have to write out the actual formula with x sub 1 in it to show that you understand what's going on. And we got 1.632 for that. 1.632. Just to get the 2 marks there, you may have to do that step. Okay, on to the next one. D, describe the long-term behavior of x sub n. So this involves continuing to put the iteration into the calculator and seeing what happens to it. So let's keep iterating. Entry, answer, entry, answer, entry, answer, entry, answer. Now, it says long-term behavior. So I would continue until you're absolutely confident about what's happening to this curve or this iteration. So if we keep going here, I eventually get to 2, and if I go one more, I get 1, 2, 1, 2. You can see then it's iterating between 1 and 2. So the long-term behavior then is it is periodic with period 2, and it's oscillating between 1 and 2. So I would say there, I think it was 1 mark, so it oscillates between 1 and 2 in the long term. And let me just check, oh, that was 2 marks. So you may have to also include the fact that it has a period of 2. So periodic with period 2. Okay, there we go. That was part D, and that was question 11 for a total of 11 marks. Question 12, part A says, prove that cosine of 3 theta over sine theta plus sine 3 theta over cosine theta is equivalent to 2 cotangent 2 theta, where theta is not equal to 90n and n is an integer, for 4 marks. So we need to prove this trigonometric identity. So let's take the left-hand side. It looks like the messier side. So let's start off with that. So we can say left-hand side is cosine 3 theta over sine theta plus sine 3 theta over cosine theta. And let's try to simplify this down to 2 cotangent 2 theta. Also, we should make a note, or just remind ourselves what the cotangent is. That is 1 over the tangent of theta, which can also be written as cosine theta over sine theta. So we may also be looking for cosine over sine. That might show that we've got the cotangent function. Okay, so starting off with this one here. Now, there are a couple ways to do this. You could split cosine 3 theta and sine 3 theta into cosine of theta plus 2 theta, because on the right hand side we have that 2 theta, so we want to get rid of these 3 theta parts of these functions. So you could do this, split it up into theta plus 2 theta, and then use the sum and difference formulas to simplify that. Same for the sine of 3 theta. There is a shortcut, as there usually is for these though. So firstly, I'm going to combine these functions, or these fractions, sorry, and to do that we want a common denominator. So multiply this one by cosine theta, multiply this fraction by sine theta, and we will have cosine of 3 theta times cosine theta plus sine of 3 theta over sine theta. This is now all over sine theta cosine theta. Now we can actually reverse one of the sum formulas to simplify this numerator. We have one of the sum and difference formulas that says cosine of A take B equals cosine of A cosine of B plus sine of A sine of B. Okay, does that right hand side look familiar? Looking at this fraction here, can you see a connection between cosine A cosine B plus sine A sine B and cosine 3 theta cosine theta plus sine 3 theta sine theta? That's right, that effectively is the same expression there. In this case we have A being 3 theta and B being theta. So we can actually reverse this difference formula to say that this numerator then will equal cosine of A take B, or cosine of 3 theta take theta. So there's a little bit of a shortcut here. I don't think that's easy to spot, and I would just say that be aware that there are sometimes shortcuts available for these like trigonometric identity types of problems, and there are always these little tricks you can use, so try to keep an eye out for them. But if you don't see them, you can still it will still work out if you use a longer method. So if you don't see it, that's fine as well. So for this one, as I said, we want to simplify this down to cosine of A take B, in this case 3 theta take theta, over sine of theta cosine theta, and then cosine of 3 theta take theta, well that's just cosine of 2 theta, over sine theta cosine theta, and then I want to use a double angle formula in this denominator. So we know that sine of 2 theta is 2 sine theta cosine theta. By extension then we can say that sine theta cosine theta is equal to a half sine 2 theta. So using that idea we can plug in half sine 2 theta for sine theta cosine theta. So then we would have cosine of 2 theta all over sine 2 theta. Now you could write the half down here, or you can think, well, if you divide by a half, it's the same as multiplying by 2. So then we would have 2 in the numerator, 2 cosine 2 theta sine 2 theta. Okay, then remember we were looking out for this cosine over sine because that's 1 over tan, which is cotangent. So here we have this cosine over sine, therefore we can say this is 2 cotangent 2 theta. And I believe that is the right hand side, 2 cotangent 2 theta. So then we can say this equals the right hand side, and we are done. Okay, so that was part A. Part B says, hence solve for theta between 90 and 180 the equation cosine 3 theta over sine theta plus sine 3 theta over cosine theta equals 4, giving any solutions to 1 decimal place. So we've just proved then that if we have cosine 3 theta over sine theta, all of this, this is the same as saying 2 cotangent 2 theta. And using this expression, it's going to be much easier to solve for theta than all of this. So we can also say that 2 cotangent 2 theta is equal to 4 and solve for theta then. So for part B, that's where I'm going to start. 2 cotangent 2 theta is equal to 4. And then also we know that theta is between 90 and 180. So then also I would simplify this to the tangent function. Divide by 2 on the right hand side, and we would have 1 over tan of 2 theta is equal to 2. And then rearrange this a little bit, we would have tan of 2 theta equal to a half. And so this is just making it a little bit easier for me to solve for theta. So then we can say 2 theta is equal to the inverse tan or arctan of a half, and get some solutions for 2 theta. So let's put that into a calculator. So the inverse tan of 0.5, I get, and I believe I'm still in radians, so I need to change this to degrees because we're talking about degrees. So let me do that again. And I get 26.565. And we also need to consider the period of the tangent function, which is 180 degrees. So we've got 26.565 and so on, plus the additional solutions to that every 180 degrees. So that is when k is an integer. Okay, so then we have theta is equal to these divided by 2. So let's just write that as 26.565 plus 180 k divided by 2. And we're only talking about when theta is between 90 and 180. So we should probably only have one solution here for theta. So this would be when k is equal to 1, because then we divide it by 2, and we should have a solution between 90 and 180. So let's go ahead and add 180 to this, and then divide by 2, and we get 103.28. You can think if 180 is, if we just do the first solution, 26 divided by 2, that's going to be 13 something. That won't be between 90 and 180. And then if we do 26 plus 360 divided by 2, that's going to be greater than 180. So we are only going to have one solution here, 103.28, and so on. And we needed to round that off to something, to 1 decimal place. So this is going to be rounded off to 103.3 degrees. Okay, so there's my solution for theta for part B. That was question 12 for 7 marks. Question 13 gives us a figure and it says a sphere of radius r has volume 4 and 3 pi r cubed and surface area of 4 pi r squared. So that's nice. They give us some formulas before we get into it. And then the question says a manufacturer produces a storage tank. The tank is modeled in the shape of a hollow circular cylinder closed at one end with a hemispherical shell at the other end as shown in figure 9. The walls of the tank are assumed to have negligible thickness. The cylinder has radius r meters and height h meters, and the hemisphere has radius r meters. The volume of the tank is 6 meters cubed. show that according to the model, the surface area of the tank in meters squared is given by 12 on r plus 5 on 3 pi r squared. Okay, so the only figure they give us in this question is the volume of 6 meters cubed, and you'll notice then that the expression for the surface area does not have any h terms in it. So let's look at this figure again. We have these two radii of r meters and this height of h meters. Now, if we were to write an expression for the surface area, it would have h in it. That would be included in the surface area of this cylinder. But in this expression, we don't have h. So we're going to have to somehow eliminate that by also using the volume formula and relating that to 6 meters cubed and then somehow plugging it into the surface area formula. So I'm actually going to start with the volume, and hopefully I can write it in terms of h and then plug that into the surface area formula somehow. So volume is equal to, well, let's have a look at this shape. We're going to have half a sphere of volume plus the volume of the cylinder. The volume of the sphere, they tell us is 4 on 3 pi r cubed, but we've got a hemisphere, so it's going to be half of that. Half of 4 on 3 is 2 on 3. So we'll have 2 on 3 r cubed for the hemisphere. And then the volume of a cylinder is pi r squared, the area of the circle, multiplied by the height of the cylinder. Okay, so we know this is equal to 6. So we can say then, well, this equals 6. Let's start off with that. And then, well, we want to, as I said, we want to write this in terms of h and hopefully plug that in to the surface area formula. So starting off, I would probably factorize everything out of these terms that I can. So I've got pi r squared that I can factorize, and then I'm left with 2/3 r plus h equal to 6. And then I could say that 2/3 r plus h is equal to 6 on pi r squared, and then h is equal to 6 on pi r squared take 2 on 3 r. So now I have an expression for h, or an equation in terms of h. Let's go ahead and write down the surface area. The surface area is going to be the surface area of a hemisphere, so that's going to be half 4 pi r squared, so 2 pi r squared. And then the surface area of the cylinder, that's going to be the outside of the cylinder, which is h times the circumference of the circle plus the area of the circle on the bottom. So we've got 3 parts to that. We've got, as I said, the surface area of the hemisphere, 2 pi r squared, plus the circle on the bottom, pi r squared, plus the outside of the cylinder, which would be 2 pi r times h. Okay, so that's the surface area, and then, as I said, we want to plug in this expression for h here to eliminate that h, and we can have, so then we can have this just in terms of r. So we'll have 2 pi r squared plus pi r squared. Actually, I could just write that as 3 pi r squared. That would simplify it a little bit. Plus 2 pi r times all of this, 6 pi r squared take 2 on 3 r. And now I just need to try to simplify this down to the expression in the question. So let's go ahead and see if we can do that. Firstly, I could expand these brackets out. So I have 3 pi r squared plus 2 pi r times 6 on pi r squared. Well, for this first term in these brackets, that 1 r and that pi, they would cancel. So I would just be left with 12 on r for that term there, and then 2 pi r times negative 2 on 3 r, I would have a negative 4 on 3 pi r squared. Okay, and then nothing else cancels there. Oh, sorry, not r cubed, r squared. I don't know why I wrote cubed there. Okay, so then simplifying further, we've got 3 pi r squared take 4 on 3 pi r squared. 3 take 4 on 3, well, 4 on 3 is like 1 and 1/3, so 3 take 1 and 1/3, that would be 1 and 2/3, or 5 on 3 pi r squared plus 12 on r. Let me just double check the expression again. 5 on 3 pi r squared plus 12 on r. That's exactly what we have there. So there we go. We have we've done part A there. Part B says the manufacturer needs to minimize the surface area of the tank. Use calculus to find the radius of the tank for which the surface area is a minimum. Right, so, we're minimizing the surface area, so they've already told us to use calculus. So we're going to have to take the derivative of this expression, and then that should give us the radius when this is at a minimum. So for part B, we are going to have to take the derivative of the surface area, and we can also start by stating we understand there will be a minimum surface area when dy and dx, the derivative is equal to 0. So then we're looking for dA on dr, so the derivative of the surface area with respect to the radius, essentially just the derivative of this expression. And it might be easier to write this slightly differently as 12r to the negative 1 plus 5 on 3 pi r squared, because then we can use the power rule on that. So using the power rule, negative 1, bring that down the front, we'd have negative 12r, and then subtract 1 from the power to r to the negative 2, plus 5 on 3 pi r squared, take that power, bring it down the front, 2 times 5 is 10, 10 on 3 pi, and then take 1 from the power, so we just have pi r. Okay, so we have that derivative now, and then let's set that equal to 0, and actually I might write this again as negative 12 on r squared plus 10 on 3 pi r is equal to 0. And I find this easy when there are no denominators, so I would multiply through by r squared. So this would be 10 on 3 pi r cubed equal to 0. And then multiply it through by 3, this would be negative 36 plus 10 pi r cubed is equal to 0. Then 10 pi r cubed is equal to 36. And then pi r cubed is equal to 3.6. And then r is equal to the cube root of 3.6 on pi. Okay, so let's put that into a calculator. The cube root of, now where's my cube root function? There it is. The cube root of 3.6 divided by pi, and I get 1.046 approximately. So 1.046, and we needed to round it off to something. Nope, but if we go back to the start of the paper, remember it says round off to 3 significant figures where appropriate. So rounding this off to 3 significant figures, we would have 1.05 meters for the radius when the surface area is a minimum. Just to answer a quick question some may have, we know that when the derivative is equal to 0, we also get a maximum, or it's a way to find the maximum. So why can we just say the minimum surface area when dy and dx equals 0? Well, this is a quadratic, right? 5 on 3 pi r squared. That's a positive quadratic looking like this. So this essentially won't have a maximum. It will only have a minimum. So that's why we're just looking for the minimum there, just in case anyone was wondering. Okay, so that was part B. Part C says calculate the minimum surface area of the tank, giving your answer to the nearest integer. So, well, we have the radius. I guess we just plug that into the surface area, and that should give us our answer. So for part C, we had the surface area equal to 12 on r plus 5 on 3 pi r squared. Plugging that in, this would be 12 on 1.05 plus 5 on 3 pi times 1.05 cubed. Putting that into a calculator, let's see what we get. Oops, sorry, I've just realized I've got that cubed and that squared mixed up. Sorry about that. So putting that in again, when we have the squared term, I get 17.2 and so on. 17.2. And let me just double check again. I always forget giving your answer to the nearest integer. Okay, so this is going to round off then to 17 meters for the surface area. Sorry, 17 meters squared for the surface area. Okay, so that was question 13 for a total of 10 marks. On to question 14. This is a fun one. I hope you're ready for this one. So question 14, part A says, use the substitution u equals 4 take root h to show that the integral of dh on 4 take root h equals negative 8 log 4 take root h, the absolute value of that, take 2 root h plus k, where k is a constant. Right, so, well, they tell us an approach to use by using a u substitution. So we're going to substitute u in for this denominator here, 4 take root h. We're also going to have to integrate this with respect to u, so we're going to have to find a different expression for dh as well. So let's get started then. We have the integral of dh on 4 take root h for part A. And we are substituting u for 4 take root h, and initially we would be integrating this with respect to h, but let's do something with this expression over here. Firstly, let's take the derivative of both sides, or if you like, just the derivative of u with respect to h. This would be, well, the derivative of 4 would just be 0, and then we're doing the derivative of negative root h. This is like negative h to the power of a half. This would be negative a half h to the power of negative a half. So a half take 1. And then we can say that du equals a half h to the power of negative a half multiplied by dh. And then we can rearrange this in terms of dh. So we can end up plugging that in there. This would be negative 2 multiplied by du. This would be 1 on root h, so then we can multiply this by root h. Okay, so actually I might write that slightly differently. This would be negative 2 root h du. Okay, so now that is in terms of dh. So plugging these into this expression then, we could say this integral is the same as dh. This would be negative 2 root h du all over u. And now I still have that h there, that root h, so I want to substitute something for that as well. So taking this initial equation, u equals 4 take root h, I want to rearrange this in terms of root h. So this would be negative root h equals to u take 4, and then root h is equal to, actually I could even use negative there and get rid of that negative in the numerator there. So this would be the integral of 2 times u take 4 all over u with respect to u. Okay, that is an integral I can do. And actually this was inaccurate up here. I don't know why I wrote that second dh there. That didn't need to be there. So that was an inaccuracy. Sorry about that. Okay, so continuing with this problem then, we have the integral of 2 times u take 4 over u with respect to u. I can expand those brackets out. This will be the integral of 2u take 8 over u du. This is, then I could separate it into two fractions. This would be 2u over u, which would just be 2 take 8 on u du. I can do the integral of this. Integral of 2 with respect to u is 2u. The integral of negative 8 on u is negative 8 log u. And then I need to add the constant on the end. Now plugging u, or 4 take root h, back in for u, I would have 2 times 4 take root h, take 8 log of 4 take root h plus c, but I believe they've used k for the constant here. Yes, so let's use k instead. And let's continue to simplify. So I would expand out these brackets here. I would have 8 take 2 root h, take 8 log of, and I believe they've used the absolute value for the log, which is totally fine. Brackets or absolute value symbols are fine. Absolute value, I guess, is more accurate. And then we still have that constant on the end. And then let's double check that expression. We had that log term out the front, and there is no constant term. There's no 8 in this expression here, which I guess they've included with that k. So actually, if I go back here, then I should keep that as a c. I should keep that as c. So add on that constant, and then when I include the 8, I'll change it to k. So this is still plus c, and then writing this as they have written it, I've got 8 log of 4 take root h, take 2 root h plus k. c plus 8, which is essentially just still a constant. Okay, so there we go. I believe we have finished up with that expression they were looking for. Negative 8 log 4 take root h take 2 root h plus k. On to part B then. A team of scientists is studying a species of slow-growing tree. The rate of change in height of a tree in this species is modeled by the differential equation dh on dt equal to t to the power of 0.25 4 take root h on 20, where h is the height in meters and t is the time measured in years after the tree is planted. Find, according to the model, the range in heights of trees in this species. So I guess we're talking about meters per year for dh on dt, and we are looking, well, firstly we're looking for the range essentially of h. So let's think about this logically. If we are talking about a tree, well, what's the minimum? It can be 0. It's not going to be really negative. Realistically, we're not talking about negative heights. So we're starting at 0, and what could it go up to? What would be the maximum height of the tree? Well, it would be then when dh on dt is equal to 0. That will give us the min and max. So let's firstly set this equal to 0 and see what we will get. Well, actually, we would have, the only possibility here is if 4 take root h is equal to 0, because t to the power of 0.25, that won't be able to equal 0. So we're going to have this term here equaling to 0, and that will give us a value for h. Okay, so for part B, let's write down that derivative firstly. T to the power of 0.25 multiplied by all of this, and height, or h, was the height of the trees, and t was in years of growth. So this is the rate of growth, and we can say this would reach a maximum when it equals 0. So we have a maximum when dh on dt equals 0. So therefore we have 4 take root h equal to 0, because that's really the only possibility. Unless t equals 0, that would be the minimum, right? That would be when the tree is starting to grow, or when the seed's planted, or whatever. So solving this, then we have negative root h equal to negative 4. Then dividing through by negative 1 and squaring both sides would have h equal to 16. So then we have the range of values for h as 0, between 0 and 16, and it could equal 16 there, and we would get 0 for dh on dt. That, I guess, is assuming no negative growth, but I think that's a fair assumption. On to part C. One of these trees is 1 meter high. When it is first planted, according to the model, calculate the time this tree would take to reach a height of 12 meters, giving your answer to 3 significant figures. And this is a 7-mark question. Okay, so we are looking for t then, essentially, when h is equal to 12. So let's start C down below. We are given a height of 12, and we're looking for t, and we're also given the derivative of dh on dt, or the rate of growth of the trees, and this was t to the 0.25 multiplied by 4 take h all over 20. Okay, well, the first thing to note, I guess, is we can't just plug in that 12 here and get a value for t, because we don't know the rate of growth. They haven't told us that. So we'd still have 2 unknowns there. We wouldn't solve anything. But hopefully it's pretty clear that there must be some connection between part A and the rest of this question. They wouldn't just ask you to do this part for no reason. So we have in part A, we found the integral of dh on 4 take root h. In this expression, we have a 4 take root h and a dh. If we rearrange this in this way, we already have that integral. So maybe we can use that somehow. So let's firstly take that derivative and rearrange it to say this would be dh on 4 take root h equal to t to the power of 0.25 on 20 multiplied by dt. And then if we integrate both sides, we'd have the integral of dh on 4 take root h equal to the integral of t to the power of 0.25 on 20 with respect to t. We already have this integral. Let's go ahead and plug that straight in from part A, and hopefully it comes in useful. So we had negative 8 log of 4 take root h take 2 root h, and we had a constant on the end there. I'm going to leave that off for now because we only want a constant on the left or the right hand side. You don't want two constants on the left and the right, because then essentially you're introducing a negative one. I'm not going to go into that in any more detail now, but basically you just want a constant on the left or the right. I'm going to include it on the right, and then we want the integral of t to the power of 0.25 on 20. Well, think of that 1 on 20 as a constant out the front. We can effectively ignore that, and then we're taking the integral of t to the power of a quarter. Well, add 1 to it and divide. So 1 plus a quarter is 5 on 4. Dividing by that, we'd have 4 on 5. And t to the power of 5 on 4, or 1 and a quarter. And that constant, as I said, I'm adding on the right hand side. Okay, so now hopefully you notice we actually have an equation in terms of h and t, and we only have one unknown. We have two unknowns. We have a constant, but we can solve for that constant because they give us the height when t equals 0. So that's why this piece of information was important. They tell us one of the trees is 1 meter high when it is first planted. So that's going to allow us to solve for the constant in this equation, and then we can plug in h equal to 12 to solve for t. Okay, so firstly, let's say when t equals 0, h equals 1. Plugging those in, we have negative 8 log of 4 take 1 take 2. 2 times 1 is 2, equal to well, all of this would be 0 because this would be 0. So this is equal to 0 plus c. Actually, I forgot why I'm doing this. So all I'm doing here is solving for c. So this is equal to c here. And then solving this, I've got negative 8 log 3 on the left-hand side. So let's say then that c is equal to negative 8 log 3 take 2. Okay, that is neat enough for c. And then going back to this expression up here, or this equation, I'm going to rearrange this or rewrite this slightly. So I'm going to write t on the left because I'm solving for t. And also I have 4 on 20, which would be 1 on 5 there, times 5. So that would be 1 on 25, t to the power of 0.25. And I also have c now, and I might add that to the other side. So if I include it on the left, it would be negative 8 log 3 take 2, but I'm going to add it to the right hand side. So I have all of this equal to negative 8 log of 4 take root h take 2 root h plus 8 log 3 plus 2. Okay, now I have an equation in terms of t and h. All I have to do is plug in h equal to 12, and I'm having issues with my Zoom. Okay, all I need to do is plug in h equal to 12 and find t. Okay, so I have then, well, t to the power of 0.25. Actually, I don't know why I wrote that. That should not be to the power of 0.25. I'm talking about the integral now. It's to the power of 5 on 4. Sorry about that. T to the power of 5 on 4. So down here as well, 5 on 4 is equal to all of this multiplied by 25. Plugging in 12, I have negative 8 log of 4 take root 12 take 2 times root 12 plus 8 log 3 plus 2. Okay, so let's plug that into a calculator. I get 221.27 and so on. 221 sorry, I already forgot the number. 2727. And then to find t, well, I could take the fifth root and raise that to the power of 4, I guess. So that would give me t. So the fifth root, and then, so I get 2.94, and then raise that to the power of 4 to get rid of that power of 5 on 4. I get 75.15, and so on, 75.15. And what was the question asking again? It was saying to 3 significant figures. So give the time to 3 significant figures. So this would be then rounded off to 75.2 years for the time. So the time it took the tree to grow to 12 meters was 75.2 years. Okay, there we go. That was question 14 and the end of the paper. So that question alone was worth 15 marks. How did you go with this paper? How did you find it? Did you think it was, one of the more difficult A-level papers, or what did you think? Let me know in the comments. I hope you found that useful. Please leave a like, subscribe if you want to see more. There will be links to everything in the description. So there'll be links to the paper and mark scheme and the playlist for papers 2 and 3 as well if you want those. Again, hope you found that useful. Good luck with the rest of your revision. I'll see you in the next one. Bye for now.